Imagine a mysterious planet where mountains, deserts, and forests do not exist because the entire world is covered by endless water stretching across the horizon like a silent cosmic ocean. Far beyond our solar system, astronomers have discovered strange worlds that challenge imagination, including one extraordinary type of planet believed to be made almost entirely of water. At first glance, such a world might sound peaceful and beautiful, but scientists believe these ocean planets could hide powerful storms, crushing pressures, and mysterious environments far different from Earth. These fascinating planets are often called water worlds, and researchers think they may contain hundreds of times more water than all the oceans on Earth combined. Instead of continents and islands, the surface might appear like a single endless ocean, where waves roll across the entire planet under alien skies and unfamiliar stars. Some scientists believe these planets formed in icy regions of space, where frozen materials and water-rich debris slowly gathered together to build massive ocean-covered worlds. Over millions of years, gravity pulled more ice and rock toward the growing planet, eventually creating a huge sphere where water became the dominant ingredient. When these planets moved closer to their stars, the ice melted and transformed into enormous global oceans that could stretch hundreds of kilometers deep. On Earth, the deepest ocean trenches reach about 11 kilometers. But on a water world, the ocean could be dozens or even hundreds of times deeper. At such incredible depths, the pressure becomes so intense that ordinary liquid water may transform into exotic forms scientists rarely observe on our planet. Researchers believe that deep beneath the surface ocean, water might freeze again under pressure, forming strange types of ice that exist even at extremely high temperatures. This unusual high-pressure ice may form thick layers beneath the ocean, creating a hidden barrier between the liquid water above and the rocky core below. Because of this barrier, the ocean might never touch the planet's rocky surface, which could make the environment very different from Earth's ocean ecosystems. Many scientists wonder whether life could survive in such conditions, where sunlight struggles to reach deeper waters and nutrients from rocks might remain locked far below. Despite these challenges, water is one of the most important ingredients for life, making these mysterious planets extremely interesting for researchers searching the universe. The idea of a water-covered planet once belonged mostly to science fiction stories, but modern telescopes have started revealing real candidates scattered across distant star systems. One famous example discovered by astronomers is a planet known as GJ 1214b, often described as a possible water world far beyond our solar system. This distant planet is much larger than Earth, and scientists believe a significant portion of its mass could be made from water and other light materials. Observations show that GJ 1214b has a thick atmosphere filled with clouds or haze, making it difficult for telescopes to clearly see what lies beneath. Even so, researchers suspect that under those clouds could exist an enormous ocean stretching across the entire planet without interruption. If someone could stand on such a world, they might see no land anywhere, only an endless horizon of water beneath a sky that looks completely different from Earth. The gravity on many of these planets could also feel stronger because water worlds are often larger and more massive than our home planet. Strong gravity might create enormous waves and powerful currents moving through the global ocean, shaping weather patterns unlike anything humans have experienced. Storm systems on such planets could grow incredibly large, fueled by warm oceans covering the entire surface and circulating energy around the globe. Instead of hurricanes forming in specific regions, massive storm belts might travel continuously across the ocean planet without ever reaching land. Scientists also think the atmosphere above these oceans might contain thick clouds of water vapor, creating a humid and mysterious climate. Sunlight filtering through those clouds could paint the sky in strange colors, depending on the planet's atmosphere, and the type of star it orbits. Some water worlds orbit small red stars, which means their sunlight appears dimmer and more reddish compared with the bright yellow light from our sun. Under such light, the endless ocean might reflect deep crimson or violet tones, giving the planet an almost dreamlike appearance from space. While the surface may look calm from orbit, the deeper ocean layers could hide extreme environments filled with pressure and unusual chemical reactions. As scientists model these planets on computers, they discover that water worlds might behave very differently depending on factors like temperature, composition, and proximity to their star. Beneath the calm surface of a water planet lies a mystery almost impossible to imagine. The ocean might plunge downward for hundreds of kilometers into darkness never touched by sunlight. On Earth, sunlight begins to fade only a few hundred meters below the ocean surface. But on a water world, that fading light may disappear quickly within a much deeper and larger ocean. As a traveler descends deeper into this endless alien sea, the environment would slowly transform into a silent world of darkness. Pressure and unfamiliar chemical processes would dominate those depths. At depths where Earth's oceans would already crush submarines, the waters of a massive ocean planet would still continue stretching downward. The pressure in these lower regions could become millions of times stronger than what humans experience on the surface of Earth. Under such immense pressure, the behavior of water itself begins to change in fascinating and unusual ways. Instead of remaining ordinary liquid water forever, the molecules may compress tightly together and begin forming completely different structures. Eventually, the water may freeze again, not because it is cold, but because the pressure forces molecules into rigid crystalline patterns. This process creates unusual materials known as high-pressure ice, which can exist even while temperatures remain extremely hot. Scientists have identified several forms of these exotic ices, each with unique structures and properties. These layers of high-pressure ice could form a thick shell beneath the global ocean, separating the liquid water above from the rocky interior. On some water worlds, this icy layer might be dozens or even hundreds of kilometers thick. Imagine an enormous ocean resting on top of solid ice that formed from crushing pressure rather than freezing temperatures. Below that icy layer could lie the planet's rocky mantle and core, hidden far beneath the ocean and almost completely isolated. This separation creates an interesting challenge for scientists who study the possibility of life on water worlds. On Earth, many ocean ecosystems depend on nutrients and minerals that come from interactions between seawater and the rocky ocean floor. Hydrothermal vents on Earth release chemicals that support unique life forms living deep in darkness without any sunlight at all. But on a water world with a thick ice barrier, the ocean might never directly touch the rocky surface where such chemical exchanges normally happen. Without that contact, the ocean might contain fewer nutrients that living organisms typically rely on for survival. However, scientists are still exploring other possibilities that might allow chemical materials to reach the ocean through cracks or slow geological activity. For example, heat from the planet's interior could slowly move upward through the icy layer, influencing ocean currents above. If fractures formed within the ice shell, they might allow small amounts of mineral-rich material to travel upward into the ocean. These tiny pathways could potentially provide the ingredients necessary for simple forms of life to develop. Another fascinating possibility involves powerful ocean circulation, moving heat and chemicals throughout the planet's massive waters. Because the ocean covers the entire surface, currents might flow freely around the globe without continents blocking their path. This unrestricted circulation could create enormous underwater currents traveling thousands of kilometers across the planet. Such currents might transport nutrients, heat, and gases from one region of the ocean to another over long periods of time. Scientists believe these movements could play an important role in shaping the climate and internal balance of a water world. The deeper ocean layers might also store enormous amounts of heat absorbed from the planet's star. Over time, this heat could slowly rise toward the surface, influencing weather patterns and storm activity above the ocean. On Earth, oceans help regulate climate by absorbing and distributing heat around the planet. On a world covered entirely by water, this effect could become even more powerful and complex. Some researchers think these global oceans might create extremely stable climates lasting for millions of years. Others believe the opposite could happen, where powerful storms constantly reshape the planet's atmosphere and ocean surface. Because scientists cannot yet visit these distant planets, much of what we know comes from computer models and advanced simulations. These models attempt to recreate the conditions inside water worlds, using physics chemistry and data gathered from telescopes. By studying how water behaves under extreme pressure and temperature, imagine observing a distant planet through a telescope where no continents or islands appear, and a single global ocean spreads smoothly across the entire visible surface. From far away in space, such a planet might look like a bright blue sphere reflecting the light of its nearby star. Scientists sometimes describe these planets as ocean worlds because water may cover nearly all of their outer surface. Without continents or mountains, the planet's surface environment could behave differently compared with Earth. Winds moving across the ocean might travel long distances because there are no large land barriers blocking their path. These winds may slowly shape the movement of ocean waves across the surface of the planet. Large areas of water can release moisture into the atmosphere through natural evaporation processes. This moisture may rise into the atmosphere and gradually form clouds above the ocean surface. Over time, cloud systems may develop across different regions of the planet. Some areas might experience thicker cloud layers, while other regions may remain clearer. Sunlight passing through clouds can create soft lighting across the water below. The appearance of the sky may depend on the gases present in the planet's atmosphere. Different atmospheric gases can scatter light in ways that slightly change the sky's color. The type of star the planet orbits may also influence the color of light reaching the ocean surface. If the star produces warmer colored light, the ocean may reflect those tones gently. Scientists often study the reflection of light from distant planets to learn about their surfaces. This reflected light is sometimes called planetary brightness or reflectivity. Careful measurements of this light help researchers understand possible surface materials. Large bodies of water often reflect light differently than rocky land surfaces. Because of this, ocean planets may show recognizable patterns in telescope observations. Waves moving across the ocean may vary depending on wind strength and planetary gravity. On a larger planet, gravity may influence the size and shape of ocean waves. Gentle wind conditions may create small rolling waves across the water surface. Stronger winds could produce larger waves that move steadily across the open ocean. Without coastlines, these waves may travel great distances before gradually losing energy. Ocean currents may also develop across the planet's surface waters. These currents can slowly move warm water and cooler water between different regions. Such circulation may help distribute heat around the planet. Balanced heat distribution may support relatively stable surface temperatures. Scientists study ocean circulation carefully when modeling possible water worlds. Planetary rotation may also influence how winds and currents move across the surface. As the planet rotates, atmospheric motion can gradually curve into large circular patterns. These patterns are similar to atmospheric circulation systems studied on Earth. Over time, stable wind zones may appear around certain parts of the planet. These wind zones may guide cloud movement across the global ocean. In cooler regions of the planet, thin fog layers might sometimes appear above the water. Fog forms when moist air cools and tiny droplets remain suspended in the atmosphere. Large fog regions may slowly drift across the open ocean under calm conditions. When fog becomes dense, distant objects or the horizon may appear less visible. During clearer conditions, sunlight may reflect gently across calm water surfaces. At night, stars from distant space might become visible above the quiet ocean. Their reflections could shimmer faintly across small waves. Some ocean planets might also experience tidal movement influenced by gravity. Tides occur when gravitational forces slightly pull ocean water in different directions. On a global ocean planet, tides may move large volumes of water across wide areas. Tidal motion can interact with winds and currents in complex ways. Scientists analyze these processes using computer climate models. These models combine atmospheric science and ocean physics. Results help researchers understand how ocean planets might behave over long time periods. Observations from modern telescopes provide data about distant planetary atmospheres. Astronomers examine how starlight passes through or reflects from those atmospheres. These observations can sometimes indicate the presence of water vapor or clouds. Such information helps scientists estimate whether large oceans may exist. Every new observation improves scientific understanding of ocean planets. Although much remains unknown, research continues to reveal how a planet covered mostly by water might appear and function in space. When scientists imagine a planet covered completely by water, one powerful question immediately appears. Could life survive somewhere inside those enormous alien oceans hidden beneath unfamiliar skies? Water is one of the most essential ingredients for life as we understand it, which is why water worlds attract enormous interest from astronomers searching for habitable planets. On Earth, life exists almost everywhere water is found, from shallow coral reefs to the deepest ocean trenches where sunlight never reaches the mysterious creatures living there. These discoveries have changed how scientists think about life, proving that organisms can survive in extreme environments once considered impossible for living systems. Deep in Earth's oceans, entire ecosystems thrive near hydrothermal vents where hot, mineral-rich water rises from cracks in the ocean floor. These ecosystems do not depend on sunlight, but instead rely on chemical energy released from the planet's interior. This process, known as chemosynthesis, allows microorganisms to transform chemicals into energy, forming the foundation of unique underwater food chains. Because of discoveries like these, scientists consider the possibility that life might exist even in the dark oceans of distant water planets. However, water worlds may also present major challenges that make the development of life more complicated than on Earth. One of the biggest concerns involves the thick layer of high-pressure ice that might separate the ocean from the rocky interior below. If this barrier prevents minerals and nutrients from reaching the ocean, it could limit the chemical ingredients needed for life to develop. Life on Earth often depends on interactions between water and rocks, which release important elements such as phosphorus, iron, and other nutrients. Without a steady supply of these materials, the chemistry of a water world's ocean might remain too simple to support complex biological systems. Even so, scientists continue exploring other possibilities that could allow life to appear under different conditions. Some researchers believe small cracks or weak regions in the icy layer might allow chemicals from the interior to slowly reach the ocean above. These slow processes might provide enough nutrients over long periods to support simple microbial life forms. Another possibility involves chemical reactions occurring directly within the water itself. Under extreme pressure and temperature, water can participate in unusual chemical processes that might create new compounds and energy sources. If such reactions happen consistently within the deep ocean, they could potentially support simple, lifelike systems. Scientists also consider the role of planetary atmospheres in supporting possible life. If the atmosphere contains gases like carbon dioxide, nitrogen, and water vapor, chemical cycles could form between the ocean and the air above. These cycles might allow basic organic molecules to form and circulate through the planet's environment. Over extremely long timescales, such chemical interactions could gradually increase the complexity of molecules within the ocean. Some scientists believe this type of gradual chemical evolution might eventually lead to primitive forms of life. Even if life does appear on a water world, it might look completely different from organisms found on Earth. Instead of fish or plants, these environments might support microscopic organisms drifting through the vast ocean. These microbes could float in the water, absorbing chemicals or energy sources available in their environment. Over time, natural processes might allow these simple organisms to adapt and diversify into more complex ecosystems. However, the extreme depths and pressures of water worlds could still limit how complex such life forms become. Some researchers believe life might remain mostly microscopic due to the challenges of surviving in such environments. Still, even simple life would represent an extraordinary discovery for humanity and science. Finding life beyond Earth would completely transform our understanding of biology and the universe. It would prove that life can emerge in places far different from our own planet. Because of this possibility, scientists are eager to study water worlds in greater detail using advanced telescopes. By observing the light passing through distant planetary atmospheres, astronomers can sometimes detect certain gases. Some gases may indicate chemical processes that could potentially be connected to biological activity. For example, unusual combinations of oxygen, methane, or other gases might hint at active chemistry within a planet's environment. However, interpreting these signals is extremely challenging and requires careful scientific investigation. Many natural processes can produce similar gases without involving life at all. This means scientists must analyze many different clues before. Even though water worlds may exist thousands of light years away, modern science is slowly developing powerful tools that could reveal their secrets and transform our understanding of planets across the universe. For centuries, humans could only imagine distant planets. But today, advanced telescopes allow astronomers to detect worlds orbiting stars far beyond our solar system. These discoveries happen when scientists observe tiny changes in starlight caused by planets passing in front of their stars from our perspective on Earth. When a planet crosses its star, the brightness of that star decreases slightly, providing important clues about the planet's size and orbit. By carefully studying these changes in light, astronomers can estimate whether a planet might be rocky, gaseous, or possibly covered by deep oceans. Another technique involves analyzing the light passing through a planet's atmosphere during these transits. As starlight travels through the atmosphere, different gases absorb specific wavelengths of light, leaving unique patterns scientists can detect with powerful instruments. These patterns act like fingerprints that reveal the chemical composition of the planet's atmosphere. Through this method, scientists may identify water vapor, clouds, and other gases that suggest the presence of vast oceans below. One of the most exciting scientific tools helping this search is the James Webb Space Telescope, launched to explore the universe with incredible precision. This telescope can examine distant planets and analyze the chemical signatures present in their atmospheres. By studying these signals, scientists can gather valuable evidence about the environments of possible water worlds. Although these observations cannot yet show the actual surface of distant planets, they provide powerful clues about what might exist there. Future telescopes currently being designed could become even more powerful than those used today. These next-generation instruments may eventually capture clearer images and more detailed atmospheric data from distant exoplanets. With improved technology, researchers hope to determine whether certain planets truly contain global oceans. Scientists are also developing advanced computer models that simulate how water worlds might behave over millions or billions of years. These models help researchers predict climate patterns, ocean circulation, and atmospheric changes on distant planets. By comparing these predictions with real observations, astronomers slowly improve their understanding of these mysterious environments. Space agencies around the world are planning future missions specifically designed to search for potentially habitable planets. Some of these missions aim to study smaller Earth-like planets where liquid water could exist on or beneath their surfaces. If water worlds are confirmed in greater numbers, scientists may begin studying how common they are throughout our galaxy. This information could reveal whether ocean planets are rare cosmic curiosities or a common outcome of planetary formation. Some researchers already suspect that water-rich planets may be extremely widespread across the Milky Way. If that idea proves true, billions of ocean-covered worlds could exist among the stars. Each of those worlds might have its own climate, ocean depth, atmospheric chemistry, and internal structure. Understanding these differences will help scientists learn how planets evolve over time in different star systems. It may also reveal how unique or typical Earth truly is among the countless worlds in space. For now, water worlds remain distant and mysterious, hidden far beyond the reach of current spacecraft. Traveling to such planets would require technology far beyond what humanity possesses today. Even reaching the nearest star system with modern spacecraft would take tens of thousands of years. Despite this challenge, researchers continue imagining future exploration technologies that could one day shorten these journeys. Concepts such as light-sail spacecraft and advanced propulsion systems are being studied as possible methods for interstellar travel. Although these ideas remain experimental, they demonstrate humanity's growing ambition to explore distant star systems. Perhaps one day robotic probes might travel across the stars and send back information about alien ocean planets. These probes could analyze atmospheres, measure ocean properties, and study the environments of water worlds up close. Even if such missions take centuries to achieve, the possibility continues to inspire scientists and engineers around the world. Meanwhile, telescopes on Earth and in space will continue gathering more information about distant planets every year. Each discovery adds another piece to the enormous puzzle of understanding planetary diversity across the universe. The search for water worlds also reminds us how special Earth's oceans truly are.